Alright, so we're going to look at small angles. Can someone please tell me, for this column here, what's the value you should get down the column? 4 decimal places.
0, 1, 0.
0, 1, 0. Alright, so that's assuming we're rounding. Okay, which makes sense. If you're familiar enough with the graphs of each of those functions, okay, and then we're going to be starting looking at that today, right, we can see that when it gets as the x value, the value on the horizontal axis approaches 0, okay, we got the y value, alright, so for your sine and tan, there'll be 0, and for your cos is 1, okay. So, when you take the sine of a very small number, it's numbered less than 0, we're going to say it's approximately equal to that same number. Okay, so it was approximately equal to that. Right, the tan is also the same case. So when we take an angle that is very small, so very close to 0, we're going to get a rounded answer of 0. But when we do it for cos, okay, we're going to approach, when cos is very small, that the value of cos of x, when x in radians is small, is going to approach the value of 1. Okay. And this result here is important, okay? Sine of x is less than the value of the x in radian, and that is less than the value for tan of x, okay? So, let's have a look at the proof. Alright, 2.5. So, I've got the circle there, centered at O. Okay, we're going to have a radius of the unit circle, so we have a radius of 1. And then we've got a value for x in radians here. Okay, so we've got the other part of the radius OB. And we're going to extend that until we have a right angled triangle, okay, at the circumference. Okay, that's how we're going to start. So, by definition, how long is arc AB?
1 radian.
Pardon?
X.
X, okay, because by definition, it is x, so when you have 1 radian formed at the centre of the circle of radius 1 unit, then the length of the arc formed by the run radian is 1 radian. Okay, and that's why that is x there. Okay, so that means that AC is going to be approximately equal to what? Yeah. Okay, so we're getting the value very small. Okay, so as x gets closer to 0, the value for AC is going to get closer to the arc length of AB. Okay, right, let's look at these following results. Sine of x. Okay, so we're using our right angled trig. So this here is x, AC is x. And so one more result, OC is approximately equal to what? As it gets small. 1. Okay, so getting approximately, says x approaches 0. So as we get smaller and smaller, the length of OC will get closer and closer to 1. Alright, so sine x is going to be your opposite, which is AC, over your hypotenuse of the right angle triangle there. Okay, so we're assuming as f gets smaller and smaller, right, so AC is x, and OC is 1. So as we get very, very small, by considering what happens to the triangle and the length, okay, sine x is going to approach x. Okay, that's that first result there. So tan of x is the opposite AC over the adjacent OA. And again, it's x over 1. So that's that result. Okay, so tan of x, as x is small, will also give that approximately that same value. Alright, cos of x. So cos using right angle triangle relation is the adjacent over the hypotenuse. So the adjacent is OA and the hypotenuse is OC. Okay, and as x gets really, really small, the length of those will be approximately equal. So cos of x is approximately equal to 1. Right, so that's how those results are done. You need to know that result, okay, and it'll help with further thinking if you understood some part of that proof. Alright, so now, triangle OAB. Right, so now we're going to look at triangle OAB. So we've got that portion here that we need to consider as well. And I want the area of that area. So, find the area of that triangle OAB. What can I do?
Find the area of the thing. Oh wait, of OAB.
Yeah.
Oh. Just it's on right angle. The sine rule.
Sine rule. Okay, so we don't know what the perpendicular height is because we don't know what the right angle formed at the base is, but thankfully we've got a simpler solution. So half AB sine capital C. Okay, so half. Now, so AB, that's really what it should be saying is OA times OB. Okay, for those intervals there. So how long is OA? 1 because it's the radius. How long is OB? Same radius, isn't it? So 1. Times sine of x. Okay, so angle x at the centre, it can be a half sine x. Right. Now we're going to look at the sector OAB. Because the sector is the area of the sector OAB is going to be slightly larger than the area of the triangle OAB. Alright, who remembers the formula for the area of the sector? A lot of R's there. Okay, so what's the radius again? Okay, is 1. So half of 1, which is 1. 1 times, half of 1 is a half. Half times theta, so the angle formed at the centre is x. So the area in simplest form is going to be half of x. Okay, so we're treating x as very small. Now, area of triangle OAC. Because the triangle OAC is going to be slightly larger than that area of the sector we just found. What I'm going to do is do a comparison of those three to show that result there. Right, so what can I write down to find the expression of the area OAC?
Half 1 times x.
Times what?
X.
Right, so everyone says they've got a right angle there. Okay, so I can do the half times base times the height. Okay, so it's going to be half times the base 1. Okay, times the perpendicular height of AC. half of tan of x. Because from what we did earlier, AC over 1 is tan of x. From what we did earlier. Right, so the area of this triangle is going to be less than the area of the sector, which will also be less than the area of the triangle outside of the sector. Okay, and that's the relation. So therefore this must be less than that, which must be less than that. Okay, and that's that result over there. So triangle OAB is less than the area of sector OAB, which is less than the area of triangle OAC. Each of them's got a half, so I can cancel all that out. Therefore, sine of x is less than x, which is less than tan of x.
Is there no symbol for sector?
So?
Is there no symbol for sector?
Not that I'm aware of.
Google it. That's inefficient.
Oh, that can be your task right now.
What?
Not that I'm familiar with. Okay, so I haven't seen that result used. If I have ever seen it, I don't know, but I'm just covering all bases. So that's there. Let's see the symbol for that. Alright, so.
There is.
Yep.
There is. It's like a little, like that, and then
Okay, that makes sense.
Like a mini sector.
like a
Ice cream cone?
No, like a sector.
like an ice cream cone. Like,
No,
but
like-
standing up. So
Hey.
up, and then, so it's a sector.
Yeah,
Draw
so
it,
you
you
draw
draw
it
it
and
in
you
into
draw it in
sector.
a sector.
Yeah.
That's cool.
Oh, there you go.
Like a trivial pursuit.
I've learned something new today. Alright.
Look, now you don't do anything first.
Okay, so from all that, the other important results. So you need to know these three. Okay, so as the angle gets small, sine and tan of x approaches that same value, and the cos of x approaches 1. Okay, now all that will also give this other limit. So the limit as x goes to 0 of sine of x over x is equal to 1. Okay? Because what is sine of x based on what I've done up there? Is x. So it's x over x, which is 1. Okay? So that's really simple.
It just seemed.
Alright, we could write a formal proof, but
Let's do it.
we'll move on. Alright, examples. So you're going to use that result to evaluate these following limits. Alright, A. So we need to take the limit as x approaches 0, sine 3x over 3x. Okay, so the rule is the sine of x over x, so x is now 3x on both top and bottom. Alright, so when they're the same, the limit will be 1. Okay?
What?
No,
I can speak dubstep. I can read dubstep. Okay.
Alright,
it's this one then.
so there's the graph of y equals sine of 3x over 3x. So as we get very, very close to the origin, okay, when we take that limit, alright, from the graph, reading the graph, at 0, it's 1, isn't it? Alright, so that's what we're really doing. Alright, B. limit as x approaches 0 of sine of 8x over 4x. Alright, I'm going to show you this first before we try and answer it. Sine of 8x over 4x. Alright,
What is that one? How does that one?
so somehow we need to show that at 0, at x equals 0, the answer is 2.
Cancel.
Oh, you're on that track. But how?
So it's 1, 2x over x.
Can't do that. No. Okay, what do I need the bottom to be? So I can use
Zero.
that. So what I'm going to do?
1. No, it needs to be 0. 1 might be. What? It's really obvious. Happens every time.
Okay, what do I need this bottom value to be?
4. Negative, divided by 4. What needs to be?
What do I need to do?
Negative 4.
Why negative 4? I'm just going to sound really smart and put a negative number there.
Oh, so good.
What do I need this to be to match that sort of context? 8x. Alright?
Oh, wow.
Speak up, I didn't hear.
Okay.
Alright, so limit of sine of 8x over. So what can I do with 4x to get it to 8x? Times 2. Alright? So 2, and I'll do the same to the top. Alright? So equals the limit as x approaches 0 of 2 sine of 8x over 8 of x. Okay, so you're going to manipulate these expressions to be able to use that limit. Okay, so it's really 2 times 1. Because sine of 8x over 8x, because they're the same on top and bottom, that will be 1, and then you multiply by 2. And that's how you get the answer. And that is that point in your graph. So effectively, when x is 0, because if I substitute in 0 and 0 for x, I'm going to have 0 over 0. Okay, you're going to have an undefined function. So that's why we need to be careful with the approach.
Fertile or infertile? Why?
So, alright, C. Alright, limit as theta of sine of 5 theta over 2 theta. Now this actually comes up a fair bit in your exam, in your HC exam. Okay, this does come up. One of the first questions they'll ask you, they could ask you, sorry, and it'll come up more than once. Right, so you need to manipulate this so that you can match what you've got in the question. Alright, because we need to change that 5 theta, so we'll call x on this. Alright, so we need to show that result is 2.5.
Do you times it by 5.5? 5 over 2?
Yes.
Ah.
Alright, theta approaches 0. Now we've got sine of 5 theta over 2 theta. So I want to change the 2 to a 5. So we really need to multiply both sides by 5 over 2. Because that'll cancel the 2 on top and the bottom here, and you're left with the 5. So it'll be 5 over 2 times sine of 5 theta over 5 theta. Okay, so you need to match the bottom with what you've got with sine on top. Okay, so it'll be 5 over 2 times 1. 5 over 2. And graphically, it's right there. Alright, any questions on that? Alright, so that's exercise 5.6.